Welcome. Have you ever landed on a website and just thought, wow, this thing feels alive? Ever wondered what the secret ingredient is that turns a boring, static page into a dynamic, interactive world? Well, that secret is JavaScript, and today we're going to pull back the curtain and see how it literally breathes life into the web. Okay, let's get into it.
Just think about the difference for a second. On the left, you've got the web of the past. It's basically a digital brochure, right? You can look, but you can't really do anything. Then, on the right, you have the web of today. Apps that react to your every move, news feeds that update while you're watching, and experiences that actually pull you in. That massive leap? That's all thanks to the power of JavaScript.
So, to really get where JavaScript fits in, this house analogy is perfect. Imagine you're building a house. The HTML is your skeleton and walls. It gives you the basic structure. Then you've got CSS, which is all the paint, the furniture, the decorations, everything that makes it look good. But nothing works yet. JavaScript, that's the electricity and the plumbing. It's the hidden stuff that actually makes the lights turn on and the water run. It's what makes the house a home you can live in.
Now, I know that word programming can sound kind of big and scary, but let's just demystify it right now. At the end of the day, it is nothing more than this. You are just giving a computer a list of instructions to follow. That is it. You're the director, and the computer is your actor who will follow your script to the letter.
So, if we're going to give instructions, we've got to learn to speak the language, right? So let's start with the absolute most fundamental building blocks of JavaScript, which, by the way, is the native language of every single web browser on the planet. First up, variables. And the absolute easiest way to think about a variable is just as a labeled box. Seriously, you give the box a name, like, say, username, and then you put a piece of information inside it. The cool part is, later on in your code, you can just shout out that box's name, and the computer knows exactly what information you're talking about. It's how our code remembers things. Okay, so what kind of information can we actually put inside these variable boxes? Well, we start with the simplest little pieces, what we call primitive data types. And I love this slide's analogy. Just think of them as the basic Lego blocks. They're the simple, fundamental pieces you're going to use to build, well, everything else. And really, there are just three main types you need to know to get started. First, you have numbers, which are, well, they're for any kind of math. Simple enough. Then you have strings, which is just a programmer's fancy word for any kind of text. You just wrap them in quotes. And finally, you have Booleans, which are the simplest of all. They can only ever be true or false. Think of them as a basic on or off switch.
All right, we have our Lego blocks. Now for the really cool part. This is where we stop just storing information and we start to give our code a brain of its own, letting it make decisions and do things all by itself. So how does a program actually make a choice? Well, imagine you're walking along and you get to a fork in the road. You have to decide, am I going left or am I going right? Believe it or not, we can teach our code to do that exact same thing using logic.
It's done with something called an if statement. Basically, the program asks a simple question that has a yes or no, a true or false answer. For example, is the user's age over 18? If the answer is true, the code goes down path A and lets them in. But if the answer is false, it goes down path B and shows access denied. It's that simple decision-making, right at the core. Now, besides making choices, what if we need to do the same boring task over and over again? Well, there's a huge principle in programming called don't repeat yourself, or DRY. And that's where loops come in to save the day. A for loop lets you tell the computer, hey, do this exact thing 50 times. And it just goes and does it so you don't have to write the same code 50 times. It's a lifesaver. Okay, so as our programs get bigger, they can get messy really fast. We need a way to stay organized and, well, to work smarter, not harder. And that means packaging our instructions into reusable little recipes. In JavaScript, these recipes are called functions. A function is really just a chunk of code that you've bundled up and given a name. You design it to do one specific task. You write the recipe once, and then you can use it over and over and over again, anywhere in your app, just by calling its name. Super efficient. And I absolutely love this analogy. Writing the function itself, that's like teaching your dog a new trick. You go through all the steps one time to teach it how to roll over. That part's called the declaration. After that's done, you never have to reteach the whole trick again, right? You just say the command, roll over, and the dog does the trick. That command, that's the invocation, or what we call calling the function.
So, we have variables for storing things, logic for making decisions, and functions for reusing our code.
But how does any of this abstract stuff actually do anything on a real web page? How do we connect our code to the buttons and text the user actually sees? Well, the secret is this thing called the DOM. It stands for Document Object Model. You see, JavaScript doesn't see a web page with its eyes like we do. It sees it as a perfectly organized tree-like structure of all the HTML parts. This tree is the literal map that JavaScript uses to find and mess with any part of the page it wants, whether it's a headline, an image, or a specific button. And this is where the magic really happens. Using the DOM as its map, your JavaScript can find that subscribe button and just wait, listening for a click. The moment you click it, your code can jump into action, instantly changing the button's text to subscribed or changing its color. You see this kind of amazing instant feedback all over the modern web. So once you really get these core ideas, variables, logic, functions, and the DOM, you've honestly unlocked a true superpower. You now have the ability to create, to build, and to bring your ideas to life right there in a web browser for anyone to see. And it goes so much further than that. Modern JavaScript can actually reach out across the internet and grab live data from other places using something called an API. You can think of an API as just a way for different programs to talk to each other. It's how a weather widget on a website gets the real live temperature, or how a game can pull in a complete list of Pokemon from a central database. It lets your little project connect the whole world. And the possibilities are they're limitless. You can start small, build a little digital clock that actually ticks, or a calculator that works. But those exact same skills are what you use to build a powerful Chrome extension for your business, or even to work on a massive, complex e-commerce site like Amazon. It all scales up. And here is the absolute best part of all of this. You don't need to buy any expensive software. You don't need any fancy, high-powered computer. Every single modern web browser you have, Chrome, Firefox, Safari, you name it, it has a JavaScript engine built right inside. The browser is your playground, and you already have everything you need to start right now. Which brings us to the most important point of this entire explainer. There is only one thing, that separates somebody who wants to code from somebody who can. And that is writing that first line of code. It's not about watching one more video or reading one more tutorial. It's about actually opening your browser and making it do something. You now have the building blocks. You have the logic. You have the map to interact with any web page. The tools are there. The playground is open. The only real question left is, what are you going to create?